My first problem here is going to be problem F3 of 1, where the crate has a weight of 550 pounds. Determine the force in each supporting cable. And what I have to do is put the cables in their F and Y components. So I know the total force of X is going to be negative T AB, because this X is going in the negative direction, of cosine of 30 plus the tension of AC of 4 over 5. Cosine being adjacent over hypotenuse, and it'd be 4 over 5 from the triangle on the full body diagram. But this would also be a total equal to C of 0, excuse me. And then the total sum of Y will be the tension of AB sine 30 plus the tension of AC to 3 over 5 minus the weight of the crate, 550, and this would all equal 0. So now that we have our variables split into the X and Y direction, now we try to solve for one of the variables, such as the tension of AC, which the tension of AC equals the tension of AB cosine of 30 times 5 over 4. Now what we'll do is use this right here and plug into our other equation, where we can move the 550 to where it's 550 equals the tension of AB sine 30 plus tension AB cosine 30 times 5 over 4 times 3 over 5. And I will break them down into their components, where the cosine of 30 times 5 over 4 times 3 over 5 will give me 550 equals 0.5 tension AB plus 0.6495 to the tension of AB. This will then add up to where it's 550 equals tension of AB. See here. 150, because we'll round that number up, by 1.15. 550 divided by 1.15, it's going to be 478.26, and then we'll round it up to where it is 478 pounds for our tension at AB. Now that we found our tension of AB, we can plug in the tension of AB into our original equation and then solve for tension of AC. So now it will look like this, where 0 equals negative 478.3, goes around it from there. Cosine of 30 plus the tension AC 4/5. Now, let me see here. I get 478.3 cosine 30. It's going to be 414. And we'll add to the other side, so it's going to be 414.2 equals, let's see, the tension of AC 4/5. We'll times 5/4 to cancel them out. 5/4. And our tension of AC will equal 517.77. We'll round off to 518 pounds. So now we found both of our supporting cables forces. Our next problem is going to be problem 3.3, and it asks determine the magnitude and direction of the angle and of F so that the particle is in equilibrium. So we're going to try to make all of our forces equal 0 in the X and Y direction. So equals 0, F of Y equals 0. So we know, like, starting with F of X equals -8, starting with this force up here, cosine of 30, minus, starting with this one right here, 4 cosine of 60, plus 5 of this force, just in the X direction, plus the force that we do not know in the X direction. Now what we can do is we can solve for F of X, where, let's see if I can do this here all in one go. 8 cosine 30 minus 4 cosine of 60 plus 5 will give me a negative, where is it? Negative 3.928, but then we move it to the other side of the equation, so now it just becomes 3.928 in the FX direction. And now we do the same thing for Y, where total sum of Y equals 8 sine 30, because we go in the positive direction, minus 4 sine of 60, going in the negative direction, minus Fy, because we know it is going down. And for this, we just solve for F of Y, knowing that 8 sine to 30 minus 4 sine to 60 equals well, hold on, I did that one wrong. I had cosine, which should have been sine. Let's try that again. Eight sine of 30 minus 4 sine of 60. We're going to get 0.535, but then we move it to the other side, it's going to become a negative. And then once we move it to the other side being a negative, we know that F of Y is going to be a negative as well, so we'll get rid of that -1 and divide it over, so then it cancels out the negatives to where it's just 0.5359 equals F of Y. Now we find the total force, which is going to be over these squared, which is going to be 3.928 squared plus 0.5359 squared. Force is going to equal 3.964 kilonewtons, which our force will equal then 3.96 kilonewtons rounded off. And now we gotta find the angle. We know the angle is gonna equal tangent opposite over adjacent. And a triangle here, it's gonna look like this. But we're gonna look for this angle, and this is our y and x. We're trying to find this, which is our final force. So knowing this, our angle equals with 3.928 on top, 0.5359 on bottom. That gives me the angle. That gives me the angle 82.2 degrees. And now we found our final magnitude in our angle.